Okay, in this video I am talking about order of operations. So even though a computer looks like it can do a whole bunch of things all at once, it can still only do one thing at a time. So programming languages have to have a way of thinking about which thing to do first. And Max does this in a graphical way. Spatial location, because it's a graphical programming language, it decides what to do first based on where it is on the screen. And it is not the way you would expect. So we read books in English from left to right and from top to bottom. Max is the opposite. Sorry, I hit my microphone. That's probably loud for you. Max is the opposite, right to left. So here's an example with some button objects. I'm going to click this very top button object, and we're going to follow the bang all the way through these colorful buttons. Oops, let's clear this so we can see exactly what it is. Okay, so I click the top one, and I have these print objects attached to each bang. So you can see the purple one here has a print object of 1, the red one print object of 2, orange 2.5, and they're printing out here almost all in order. 1, 2, 2.5, 3, 4, 5.5. We're going to get to that in 1 second. Let's start over here. So it started on the right-hand side. The rightmost object was this purple bang. It was the first one to get printed. And then we started moving over to the left. This is 2. And then we have 2.5 down here. So this one is still also to the right of this green button object here. So that makes sense to you, but also if I were to move it over, so now this is more to the left than this, it's still going to happen in order. Okay, because 1, let's make sure that was true, 1, 2, 2.5, yep, 2.5 still happened before 3. Why? Because in addition to right to left, we also have what's known as depth first traversal, which is pretty confusing in that it's looking for the whole line. It's going to finish everything on that stream here all the way down before it moves over back to the top. So then we went back to 3, so here is here and here is that, and now we've done everything that was after this rightmost bang, so now we can return to the top and finally get over to 4, this fourth blue button here. And then we have the last one, 5, and I have 5.5 here. So these were out of order. 5.5, which is the black one, actually happened first before the gray one. Why was that? Even though you're kind of thinking like, yeah, this is sort of to the right of this, it looks like it. It's actually not. These two button objects are exactly vertically aligned. And in that case, Max needs a way of saying, well, which one is it going to be? And Max chooses bottom to top. So it chose the black one first and then the gray one. If I take this and I move, whoops, I got both of them, move this black one over, let's move print 2, so that it actually is to the left, then it comes actually last, which is great, 5 and 5.5. Or if I wanted, I could put it above. Let's do that just to illustrate, and Command Y to exactly align, and then we'll hit this, and this should also be right, and it is 5 followed by 5.5. Okay, so now that we understand right to left, bottom to top, and depth first traversal, let's look at an example. So this is a basic step sequencer, and what I'm thinking of doing is playing these different samples at when I get through numbers in a counter. So if I'm playing, for example, an 8-beat song, on beat 1, I want to hear the conga 1. On beat 2, I want to hear the conga 1. On beat 4, same one. On beat 5, I want to hear the conga 2. Beat 7, conga 3, and beat 8, conga 4. So I have some sort of looping sequencer here. I'm going to turn this on and just listen to what it is as I have it set up here. So you might think that with these equal objects, that we could set up something like this that would work, right? That would say, on beat 1, so when my counter gets to beat 1, then play this. On beat 2, also play this. On beat 4, also play this. But watch what happens. I'm gonna walk through here. I'm gonna hit 1. Okay, it played. When I go to 2, I get nothing. 3 doesn't have a number. 4 should have played this conga. It didn't. Let's see what 5 does. It plays. 6 is connected up, right? So it should play. It didn't play. Same thing, 7 should play here, and then 8 should play here, and it does. So what's going on here? What is going on here is that we have an order of operations failure and a note about how equals works. So the equals object, which is a logical comparison to say, if you're sending it in a value and you're saying, hey, is it equal to this number? If it is sending out a true in the form of a 1. And if it is false, it's sending out a 0 in the form of a 0. False, sorry. False in the form of 0, did I say that right? I don't even know. Okay, so that's right, 1, right? So then we're gonna take another toggle and we're gonna look here. And we're gonna ask this toggle, is it true? Yes. Okay, so yes, it says 2 is true. Yes, it should be playing. Why this is sending out a number 1. What's happening here is you'll notice that this toggle also turned off. When this one turned on, this one turned off, which makes sense because this number is no longer 2. It's 1. Sorry, it's no longer 1, it's 2. So this one has to say, hey, I'm not 1 anymore, I'm 2. It's false, here's a 0 for you. So what happens is that I send this 2 into this equals object. It goes, yep, I'm a 2, sends out a true down to the playlist to play it, and then immediately after that, this 2 goes into this equals box number 1 here, right here. And that one says, whoop, no, I'm not a 2, here's a 0. And that 0 comes in right here to this playlist. So it is happening that the true says, yes, hey, it's true. Play this conga. But then because of order of operations, because Max is reading right to left, the 2 happens first, then the 1, and the 1 overrides it so quickly that we didn't even notice that this didn't even have a chance to start playing. So this is not going to start playing on a 2, and this is not going to start playing on a 4 because this is overwriting. The 5 works. The 5 works because, okay, because the 5 is on the left of the 6. The 6 does not work because the 6 says, yep, true, play this. And then immediately after that, the 5 says, nope, I'm not a 5, that's a 6, send a 0, and it turns off the playlist. So this can be really frustrating because it's somewhat invisible. Let's zoom back out and let's figure out how we can fix that. So there's a couple of ways. You can do this with a logical OR, which is right here. This is the straight up and down line that's right above your enter or your return key. Press shift to get that. It's on the forward, no, the backslash. Logical OR says, hey, if this one is true, then send a true. Or if this one is true, then send a true. So now if we send a 1, here we go, here's our, whoops, sorry. Here's a 1, here's a 2, we're playing it. Here's a 4, the 4 is still not working. So we need another logical OR here to say, if this one is true or this one is true, send a true. Or if this one is true, we can chain them together to then have them work. So you could do it like this. Let's just verify that I did it right. You just never know. 1, 2, 4. Excellent. That works. You could also do this with a select object. So we could take this number in here. Now the select is sending out a bang through different inlets. Sorry, through different outlets. So we don't have the same sort of order of operations issues because we get the bang out of different inlets, sorry, outlets. It's very late here. So the only catch here is that the playlist object doesn't respond to a bang. It only responds to integers. So we would have to hook these up to the number 1. So we could say, hey, when you get a 1, play this one. When you get a 2, also play this one. When you get a 4, also play this one. Let's just verify that that works. Get that. Just never know. Oops. Ah! Okay. Uh-oh. Did it work? I wasn't paying attention. 1, 2. It didn't work. Oh, because these are still connected. These are still connected. Okay, there we go. 1, 2, 4. Okay. All right, so the select object is a solution to this as well. What else could you do? I like select. Let's go with that. Okay. Hopefully order of operations and understanding how this is working and remembering that objects are sometimes outputting data even when they don't look like it can really help you understand what might be going wrong in your patch at any given time.